All right, this is Geometry A, Unit 7, Lesson 4, the second video, which is on altitudes. So let's define what an altitude is. Okay. In order to define the altitude, we need to remind ourselves how to construct a perpendicular to a line through a point that's not on the line. So let's say we have line L and a point P that's not on line L. In order to construct the perpendicular through P to L, put your compass point on P and draw a circular arc that crosses line L twice, resulting in the intersection points A and B. And then we're going to draw an arc from A below L and an arc from B below L, but the arcs from A and B are copies of each other, same setting, resulting in intersection point C, and then draw a line through P and C. Okay, so that's how you construct a perpendicular to a point through a point not on a line. Okay, and that's what we're going to do in our triangle. So let's zoom out a little bit here, and let's do that for a triangle. Okay, so let's start here with an orange triangle here. So draw a nice large triangle. Okay. And we're going to draw the altitudes of the triangle. The altitude is a line connecting a vertex to the opposite side, but at a right angle to the opposite side. When we did medians, it was connecting the vertex to the midpoint. In this case, we're connecting the vertex with the opposite side at a right angle, so it's not necessarily going to go through the midpoint. So, in other words, let's grab a compass here and extend the compass so it touches twice. There is no nice shortcut, by the way, for this. Okay, and I'm going to shorten the compass here because otherwise it becomes a little cumbersome here. Okay, draw an arc from both intersection points and draw an altitude. Okay, so a perpendicular through a point to the opposite side. Altitude. Okay. All right, so that's one of them. We need three of them. So let's go on and do the other three. So vertex. Now, constructing it for an obtuse triangle may mean that you need to extend the sides. So let me go ahead and do that here in this particular case. So it may become necessary to extend a side of the triangle like this. Okay, extend a side, because sometimes the altitude can actually be outside the triangle. It won't in this case, but for obtuse triangles, some of your altitudes are going to be outside the triangle. Okay, whoops, wrong tool, compass. Okay, so here we go. Let's go here, draw an arc that crosses twice. Notice one intersection point is inside the triangle or on the triangle and the other is not. It's outside the triangle altogether. Okay, so let's go here and draw the altitude there. Okay, so there's two altitudes. And we're going to draw the third altitude. Okay, so grab our compass, put our compass point on our vertex, draw an arc that crosses the opposite side twice, Okay. Go to one of the intersection points, draw an arc outside the triangle, and copy that arc to the other intersection point and draw the altitude from there. Okay, so an altitude makes a right angle with the opposite side and goes through a vertex. Okay, and notice they are concurrent. They meet at a single point. So the segments are called altitudes. And they meet at a point called the orthocenter. Ortho means straight or perpendicular. So you've all been to have heard at least of the orthodontist. Orthodontists are specialists in dentistry that work on straightening your teeth. They want to make sure your teeth are perpendicular to your gum line, straight up and down. Orthotics are inserts you can put into your shoes to help you stand upright, right? So, and there's a store called the actually, I want to say Orthocenter, but there are stores that have ortho in it, and they're usually furniture stores, right? Because they're upright, they're straight. Altitudes meet at a point called the orthocenter. Let's go to GeoGebra and let's take a look at the orthocenter in GeoGebra. Yeah, that's not what I wanted. Okay, there we go. All right, so you're going to draw a triangle. And for this one, I want the perpendicular to a line. Okay, so perpendicular to a line tool, click on a point A and click on the opposite side. There's the perpendicular. Click on the point B and click on the opposite side. There's the perpendicular from B. And from C, there we go. So these are altitudes. Each line goes through a vertex and is perpendicular to the opposite side. They meet at the point called the orthocenter. All right, so let's grab the move tool and see if we can figure out what the orthocenter does. Now, the orthocenter looks like it's actually on the angle here and outside the triangle here. So now the orthocenter can be inside, on, or outside the triangle. Now, for the circumcenter, that happened when it was on the triangle when there was a right angle. Well, let's examine the angle here. So let's measure the angle. Angle, measure angle ACB. Okay, right now this angle measures 104.3, so that's an obtuse angle, and the orthocenter is outside the triangle. Okay, when I change C so that it's right on the orthocenter, and the orthocenter is the same, the angle is 90 degrees. Look at that. So for a right triangle, the orthocenter is on the right angle, on the vertex of the right angle. And when the orthocenter is inside, the angle is acute, and all the angles are acute. So the properties of an orthocenter: for an obtuse triangle, it is outside. It's beyond the beyond the obtuse angle. Okay. For a right triangle, it is on the right angle vertex. And for an acute triangle, it is inside the triangle. All right. That's it.